Okay, so I hope my screen is visible. Okay, so yesterday we discussed about means how the dependency occurs. Okay, there are different type of dependencies like a data dependency, name dependency, and control dependency. Okay, data dependency, name, and control dependency. There are three type of dependencies that occur, and because of the data dependency, delay occur. Okay, delay in the execution of the instructions. Okay, delay in the execution of instructions. Okay, and like here we discussed example, like this is the first instruction, second instruction. So while executing the instruction, so this is a add a double word add type of instruction. Okay, the addition of R2 plus R3 store the result in R1 register. So this value of R1 means second instruction, it is using the value of R1 plus R5. Okay, because it should get a updated value of R1. So there is a dependency there. Okay, because you know in the parallel execution, okay, for a 5 stage pipeline, so this particular instruction will take a 5 cycles to execute the first instruction, and in the second instruction, like it parallelly it fetches it fetch the operands and all, so it won't get the updated value. Okay, it has to wait. So likewise, uh, here, so here you can see this is first instruction, second instruction, third instruction. So here also F4, this is a one type of processor instruction. Okay, how the result it is depend. So यहाँ क्या है F4, F4 is a register. Then multiplication instruction, it requires the F4 value. यहाँ देखो F4 and F6 multiplication. Okay, and this instruction it is depend upon the second instruction. Okay, तो वैसे कैसा डिपेंडेंसी है, second instruction depend upon the first instruction, third instruction depend upon the second instruction. So there is a dependency, so because of that uh, delay occurs. Okay, and name dependency means there is a same name. Okay, for example here, see here, f0 and f2, f0 plus f2 both are adding and the result stored in f4 register. f4 is a register, और इसमें क्या हो रहा है f3 and f5 storing in f4 register. Okay, so both are using the same registers. So sometimes what happens, there may be conflict. Okay, so that's why in data hazard there are three type of classifications are there. Okay, you should note this one. And the data hazards are named by ordering in the program that must be preserved the order of execution of instruction, the order of execution of the instructions. Okay, order of execution of the instruction that must be preserved by the pipeline. Okay, order means one by one. Okay, like for example, in your roll number. Okay, suppose here your roll number, suppose if I call like 1 2 3 4 5 6, so first one roll number 1 should come, after that roll number 2 3 4. Okay, so one by one, then only we'll get a correct results. So here, based upon the like hazard that occur, okay. So here the data hazards are classified into RAW, WAW. RAW means read after write, write after write, then write after read. So here what is this? J means second instruction. Like suppose if there is a I instruction, उसके बाद है J instruction. Okay. J tries to read a source before I writes it. तो यहाँ क्या है? There is an instruction. For example, add R1, R2, R3. Okay. So here subtraction, suppose subtraction R4, R1, R5. Okay. I hope this instruction is visible. Okay. तो यहाँ क्या हो रहा है? Suppose this particular J instruction, it tries to read a source. Source means ये वाला R1 का value, R5 का value. So J tries to read a source before the I writes to it. Means R2 and R3 ये ऐड ऑपरेशन क्या है? कंटेंट ऑफ R2 R3 दोनों एडिशन होता है और R1 में स्टोर होता है. ओके. R2 plus R3 it stores in R1. Okay. So यहाँ R1 में in R1 it is not stored and this instruction is fetching the R1 value. Okay. So J tries to read the source before the I writes it. I writes it means what? It should update the like because R1 may be some value. Previously suppose it is having some 3 value. Okay. R2 कितना है? R2 and R3. This is 5. This is 4. Okay. R2 is 5. R3 is 4. तो यहाँ एडिशन होने के बाद क्या होता है? R1 is 9. तो it should replace by 9. Okay. So read after write. So this type of hazard will occur. Means it gives an incorrect result. Okay. Incorrect result. So J instruction, it is trying to read a source, is trying to read a source before I writes it. Okay. So it create a problem. Problem means we will get a wrong result. Okay. So this type of data hazard will occur. Read after write. Reading the data before write. Okay. So that's why this type of the architecture, it should read the data after write. Read like here, read the R1, read R1 after write the here this particular instruction. So based upon the order of instruction, okay, hazards are named by the ordering in the program that must be preserved by the pipeline. Okay. To get the correct value, it should read after write. Okay. Then write after write means J tries to write an operand before it is written by the I. So write after write, then only we will get a here we will get a delay, but we will get a correct result. Okay. We will get a correct value, updated value we will get. So that's why write after write, then write after read. Write after read. So J tries to write a destination before it is read by the I, so that it incorrectly gets the new value. So write after read hazard arises. from an independence and normally cannot occur in the static issue pipeline. So RAW, WAW, WAR, RAW, right after read. So these are the three type of data hazard: read, after write. Means read the data after writing, so that we will get a correct value. Write after write. Okay. Once the data is written, then we can access. Write after write. Write after read. Okay. If we won't follow this, then we'll get incorrect value. We'll get a incorrect value. Okay. RAW, WAW, WAR. So there are three types. So here the same it is represented here. Okay. The classification of data hazard. So you may get a question. What are the different type of data hazards? That is the read after write, RAW. So J tries to, here you have to explain with example. So there is a I instruction, J instruction. So here the instruction J, it is try to read. Okay, this particular instruction J try to read a value before the I writes to it. Okay, so write after write means here both instruction I also writing to R1 and instruction J also writing to R1. So first, if I instruction completes, I completes the write operation. After completing the I instruction, write operation, then you proceed for the J operation. So write after write, then write after read. Okay, write after read. So these are the three classification of the data hazards. So data hazards and pipeline. You know these are the okay different type of data hazard will occur. So data hazards and pipeline stall. So do all kinds of data hazard translate into pipeline stall? So just now we discussed different types of data hazards. Do all kinds of data hazards that translates into the stalls? So no. Okay. Whether or not a data hazard results in a stall, it depends upon the pipeline architecture. Okay, the pipeline architecture, it depends upon the pipeline architecture. For the simple 5-stage risk pipeline, as we discussed yesterday, 5-stage risk pipeline, only the RAW, read after write hazards, RAW, read after write, okay, read after write, that hazards result in a pipeline stall and instruction reading. Okay, means it depends. See, for this particular 5-stage pipeline, this particular RAW type of hazard, this result in the pipeline stall. Okay, so in our academic for study purpose, we are using the 5-stage pipeline, 5-stage pipeline architecture. Okay, 5-stage pipeline architecture. So for this particular 5-stage pipeline, it affects RAW, read after write, this type of hazard that results in the pipeline to stall. Okay, only RAW type of hazard. So instruction reading a register needs to wait until it is written. RAW means what? It has to wait. So this type of RAW, it has to, means wait till it writes. Okay, तो यहाँ some थोड़ा delay आएगा. will get a delay because still it is not written. Okay, read after write. Okay, you need to wait. अभी suppose आपने in the hotel, suppose आप in hotel, okay, if you are ordered food, if you ordered food, then you need to wait for some time. And if you do like hurry, if you hurry to go, and then you will get some, you won't get a proper food. Okay, proper cooked food you won't get. Okay, so you need to wait to get your food. So the WAR, right after read, and WAW, right after write, hazards that cannot occur because all instructions take 5 stages. All instructions that take 5 stages. Read happen in the second stage, write happens in the fifth stage, and no way for write from the, as we discussed in the last class. Okay, so this is the instruction fetch stage, then instruction decode and read operand or read register, then there is a instruction like execution, no, execution stage, then data memory, here instruction decoder, instruction memory, then write result. Okay, so likewise these are the stages. Okay, so in this particular stage, here we are reading the instruction, means reading the operands. Instruction decode means reading the operands. Here write result means each instruction takes 5 clock cycle. So that is our 5-stage pipeline. Okay, so what are the techniques to reduce the data hazard? Now this is important. What are the techniques to overcome or to reduce, okay, to reduce the data hazards? How we can overcome to reduce the delay? Okay, so there are some techniques are there, like forwarding and bypassing. Okay, first technique is forwarding and bypassing, bypassing. Then basic compiler pipeline technique, dynamic scheduling with renaming. Okay, and hardware speculation means hardware speculation, as the name indicates, it depends upon the hardware. Okay, hardware. So these are the techniques to overcome or to reduce the delay in data hazard, to reduce delay in data hazard. We'll see first one. Okay, so how we can implement this forwarding technique? Okay, forwarding and bypassing technique. So here, to support the data forwarding, addition hardware is required so that multiplexer is allow the data to be transferred back and control logic for the multiplexer. So here the forwarding technique. Okay, how we can avoid the data hazard using the forwarding technique? So it is very important how you can avoid the data hazard. Okay, how you can avoid? So here you can observe, so here this is the first instruction. Okay, first instruction, second instruction, third, fourth, and 5 instruction. And this is our 5-stage pipeline. So this is instruction fetch, then instruction decode or the reading the operand, execution stage, then data memory, then write result. Okay, these are the 5 stages. So for every instruction they will pass through 5 stages. Okay, all instructions they pass through the 5 stage. So here so as already we discussed this type of architecture and the same instructions, like here add instruction is there. So this add instruction R2 and R3, it adds and result stored in R1. So this R1 it is used by the second instruction, and also it is used by the third instruction, and also fourth instruction and fifth instruction. All instructions are depend second instruction, third instruction, fourth, fifth. All instructions are depend on first instruction. Okay, this is the first instruction. ये तीनों को R1 का वैल्यू चाहिए, and we already know like some delays occur in these two instructions we discussed in the last class. Okay, now we have to avoid that delay. Okay, so here you can observe during the first clock cycle the instruction is fetched. Okay, so during the second clock cycle the second instruct this first instruction is in the decoding stage or reading the operands and all. Okay, instruction decode or reading operands. At the same time the second instruction is fetched. Okay, then during the clock cycle 3 the execution unit it is performing the operation. This is here ALU operation, ALU. So yeah, actually arithmetic logic unit is there. Okay, so this execution unit it is performing an operation like यहाँ तो data read हो गया, second in second clock cycle data is read like R2, R3. Okay, but in this it performing an operation R2, suppose here performing an addition R1 equal to R2 plus R3. Okay, then at the same time the second instruction is fetched. Okay, the second instruction is fetching, but here second not fetching, here the it's a decoding stage. Okay, okay, so here what happens now, uh, here we are adding one bypassing circuit, because yeah, actually if we follow the pipeline we will get a result at this stage. ये लास्ट स्टेज में हमको फर्स्ट इंस्ट्रक्शन का रिजल्ट मिलता है. Okay, but here what we are doing here, यहाँ addition तो यहाँ हो जाता है. Okay, like ALU means it perform the addition R2 and R3, and it is not storing in R1, but we will get that result. Okay, because ALU means it perform the arithmetic operation. So here in this particular ये जो डेटा है अवेलेबल रहता है यहाँ आने तक. ये बफर जो लैच सर्किट है यहाँ, लाइक सपोज R2 2 R3 is 3, तो R2 plus R3 ऑपरेशन होता है और रिजल्ट है 5, and it is not written in R1 but this 5 is available. Okay, तो हम क्या करते हैं, we are adding one extra hardware circuit and we are fetching. Actually normally यहाँ से लेना चाहिए, means the instruction will give the result like by storing the data into R1 and all, but यहाँ result available है because ALU is performing arithmetic operation. So we are using one extra hardware, means extra hardware circuit, and we are fetching that value to make it available for the second instruction, so that instead of waiting for the till to get a result, because here arithmetic means हमको यहाँ मिल रहा है डेटा मिल रहा है, तो we are using an external hardware. Okay, so here you can see this is the instruction decoding stage, this is execution stage. Okay, then it is a data memory fourth stage, and it is write result. Okay, second stage है, third stage है, fourth stage and fifth stage. So here what we are doing, एक्चुअली यहाँ ऑपरेट एडिशन हो रहा है, यहाँ R2 प्लस R3 का एडिशन हो जाता है. ओके, so here we are using some multiplexer circuits and here यहाँ से हम क्या कर रहे हैं, डेटा ले रहे हैं, we are taking the data. एक्चुअली ये क्या होता है, नेक्स्ट इन द फोर्थ क्लॉक साइकिल इट विल प्रोसेस टू दिस, उसके बाद फिफ्थ क्लॉक साइकिल यहाँ, एंड वी आर गेटिंग द रिजल्ट. नॉर्मली it will do the operation, but यहाँ already available हो रहा है, like R1 value, we are getting that R1 value क्योंकि addition यही हो रहा है. okay, 2 plus 3 addition हो रहा है यहाँ. So by adding the extra hardware and we are fetching, it is like suppose it is a pipeline, water pipeline. Okay, so this is a water pipeline. This is the in and out, this is input, this is output. So what we are doing, अभी कैसा है, this is one particular area 1 and this is area 5, some area. okay, यहाँ in है और यहाँ out है. okay, so here there is a very small area, some people they live here, area some 2. okay, some small area is there and they require a water. So what they do, actually they used to get यहाँ से यहाँ आता है. okay, they will get here pipeline is there, small pipeline, but actually यहाँ नज़दीक होता है उनको. So what they do, they will make a hole and they will get the water. Suppose if it is taking suppose 2 hours और पानी यहीं से जा रहा है, उनसे उनका नज़दीक है यहाँ, like suppose there is a 10 minute, यहाँ आउट जाके यहाँ वापस आने तक it will take more time. So they will put a hole here and they will take water. okay, so this is the how we have to make an arrangement, because the data is available. So data available है तो we can take. Suppose if the data is not available, if there is no data, then we cannot do anything. But यहाँ आ रहा है and we can make a hole and we can take. okay, so this is the how we can do. okay, it's the same way here. यहाँ data available आ रहा है, यहाँ आ रहा है यहाँ. okay, or you can like see here, suppose you are ordered food in a hotel. okay, you are ordered the food and suppose you are here your pizza center and okay, so you are here standing here, means you are outside of okay, and online delivery. okay, means you have done online delivery and you are at the near to pizza center. okay, and if you do the like it will take some time to deliver, means like suppose like for online processing, no, like they will accept the order and all. okay, they will process. Suppose if you are near to the pizza center, okay, So you can directly go and you can order. Okay, so instead of waiting more time, so the main thing is avoiding the delay. Suppose if you are at home, that is different question. If you are at home, then there is no option, you need to receive the online order. But you are outside or near to center, pizza center, then it is better to go and have it. So these are some, like, the main thing here is you are getting the data immediately. Okay, instead of waiting, instead of following all the procedures. Sometimes, no, like, to get some documents and all, to get some authorized or signed document. Okay, suppose if you want some signed authorized document, like for attested and all. Okay, so instead of like there are, so this is the main officer. Okay, and below that there are some different officers are there. Okay, here one more officer, and this is you. So to get your document signed, okay, so you need to follow the proper channel. You have to write an application and you have to give to this particular officer. Then he will forward to this, he will forward to this, he will forward to this, and again it will get it signed. Okay, so if you are, suppose if you are directly, means if you can approach, okay, you can, like, you can directly approach or you can get it signed instead of, because this will take, suppose 1 hour to complete the procedure. Suppose if you are such an opportunity to get directly get signed by the main officer, then you can complete it in 10 minutes instead of waiting. This is also way. Here you are getting this way you are getting, but it is taking more time. So here what we are doing, we are adding an extra hardware to support the data forwarding. Additional hardware is required. So multiplexer that allows the data to be transferred back and control logic of the multiplexer. We are adding on extra hardware and we are getting the data. So in this way we are avoiding the stop. But there are some cases are there, like we cannot avoid. Okay, we cannot avoid the, like, suppose this is the instruction. Here there is a load instruction is there, subtraction and or. Okay, so here you can observe load instruction, it loading the R1 register, then subtraction R1 and R6, store the result in R6, R4. Okay, so second instruction depend upon the first instruction, it is using R1 value. Okay, so here load operation means load and store, these are memory related instruction, memory related instructions. Okay, तो एक्चुअली यहाँ क्या है, द आवर आर्किटेक्चर 5 स्टेज आर्किटेक्चर इज देयर नो in clock cycle 3. Okay, in clock cycle 3. Okay, here the arithmetic and ALU operation, arithmetic logical unit operation will be there. Okay, ALU operation. Okay, in ALU means in clock cycle 3. Okay, arithmetic logic unit in clock cycle 3. Okay, then yeah, cycle 4, here there is a data memory. Okay, data memory means it handles the memory related. Okay, data memory is the stage. Okay, data memory stage. Okay, data memory stage. Okay, so data memory means this particular cycle 4, it handles the memory related instructions only. Okay, memory related, because ALU means it only performs some arithmetic and logic instructions, so we cannot get here the data. So this load operation is there, no? So here we will get at the end of the clock cycle 4. Yeah, ये जो buffer है latch, so from there we have to fetch. Okay, and here the data is not available for the second instruction, because second instruction को यहाँ data चाहिए, किसको? second instruction को, क्योंकि here in the clock cycle 3 it is performing the subtraction operation, right? Okay, it is performing the subtraction operation in the clock cycle here 4, बट यहाँ अवेलेबल नहीं है, क्योंकि एट द एंड ऑफ द 4 यहाँ ये बफर में यहाँ से मिल रहा है हमको डेटा, तो यहाँ डिले आएगा ही, देयर इज ए 1 क्लॉक डिले। पहला 2 आता था, अभी वी आर reduced to 1 delay, means we cannot avoid such stalls because our architecture is like arithmetic instructions are handled by, execution is handled in the clock cycle 3, and memory related in the clock cycle 4. Okay, so that's why it's unavoidable stall and unavoidable stall. Okay, and the basic compiler technique. Okay, so basic that is one way, like forwarding technique is one technique to overcome the data hazard. Forwarding bypassing technique. Okay, forwarding bypass technique is the one technique to overcome the data hazard. Okay, but in that also there are some hazards are there we cannot avoid. Okay, the main thing is to how much possible we have to avoid. Then basic compiler pipelining technique. So the idea is to find the sequence of unrelated instructions. Okay, unrelated instructions that can be overlapped in the pipeline to exploit the instruction level parallelism. Means here we need to find out some unrelated instructions. Okay, so for example here one instruction is there, R1 comma R2 comma R3. Okay, then subtraction R5 R4 R8, multiplication R10 R11 R12. Okay, then addition, subtraction, again there is a one add. Okay, here we are using R1, then R9, then R13. So here you can observe the first instruction. Okay, it performing the addition, storing the result in R1. So this R1 is the register. So second instruction R4 and R8 storing in R5. R5 is not dependent on first instruction. Okay, even the third instruction also R11 R12 so it is also not dependent, means that so these are independent instructions. Independent instructions. Okay, here fourth, but here dependency is there, this particular R1 value. Okay, but normally like it is a fourth instruction. Okay, so fourth instruction means what? It won't create any problem. So here means we will get the data, ये जो data यहाँ मिल जाता है यहाँ. Okay, okay, so here the fourth instruction means we will get the data here. ये addition करने के लिए यहाँ मिल जाएगा fourth instruction के लिए. So no need to worry about that. Means here the main thing is like the compiler will identify some dependent and independent instruction and it rearrange डिपेंडेंट एंड इंडिपेंडेंट इंस्ट्रक्शंस। ओके, ये जो डिपेंडेंट इंडिपेंडेंट इंस्ट्रक्शंस है ना, सो कंपाइलर विल आइडेंटिफाई। ओके, compiler will identify the instruction and it rearrange. Okay, it rearrange the instructions. Okay, so that we discuss in the next class. Okay, so here the same example here. See here, there is one more instruction. Load instruction is there, add instruction is there. Okay, and again the load instruction. So execute at the end of the fourth clock cycle, the same thing means here. ये जो इंस्ट्रक्शन है लोड इंस्ट्रक्शन। ओके, यहाँ क्या है, R2 रजिस्टर है। ओके, एंड हियर R4 मीन्स it is loading into R2 register. Some value it is loading into R2 register. Okay, I will write it clear. This content I have taken from the slide. Okay, so here you can observe the load instruction is there. Okay, and here second, this is the first instruction. Second instruction क्या है, add instruction. Okay, so in the first instruction you can observe the R2 is loaded. Okay, and in add instruction R2 and R3, so there is a dependency is there. Second instruction depend upon the first instruction. Then third instruction is there, no, so that is load R5, loading R5 register. So here you can observe the first instruction and third instruction, they are not dependent. They are not dependent, right? There is no dependency. First instruction and third instruction, there is no dependency, you can observe. Okay, so here is A person, B person, C person. A person is different, C person is different, B is different, and there is no dependence. ये दोनों same. Suppose A is from IT, B is from IT, and C is from civil. Okay, so during the examination, okay, so these guys A and B will discuss. Okay, they do copy, like there is support dependency because same question paper they will get. ये C है ना, C is civil student from the civil, there is no making of copy because his subject is different. Okay, during the examination hall. Okay, तो यहाँ हम क्या करते हैं, compiler will arrange. Okay, like here it will rearrange the instruction and it will add the independent instruction in between. Okay, here the compiler will add the independent instruction to avoid the stop. Okay, here first instruction is there because it is independent. Independent means there it will execute by their own. Okay, actually the why we are doing this technique means to avoid the stall, because when we perform the execution of instruction parallelly. Okay, because in one particular clock cycle it executes the parallelly. Okay, so compiler what it does, it will rearrange the instruction. Okay, and it will add this independent instruction. Okay, here likewise you can see the complete ये जो ऊपर का है, this is the original, this is the original instructions. Okay, this is the original instruction. Okay, this is the original instruction and here second is rearranged. ये जो second है ये ऐसे rearrange कर लेता है. इसको नीचे और इसको ऊपर, because it is independent instruction. Okay, because this instruction is using R5 register, R4 register, so it will do their operation. Okay, because the main thing is to avoid the delay, to avoid the delay in execution. Okay, so that is your second technique. So there are total two techniques are there in to avoid the data hazard. So one is that forwarding technique, data forwarding technique, data forwarding and bypass. Okay, means we are using some extra hardware and we are fetching the data because the data is available, so we are fetching. And one, there is compiler technique, instruction compiler technique. Okay, so these are the two techniques. Okay.